If you check your horoscope today, the sign you identify with is likely physically incorrect. The sky has shifted significantly since the zodiac maps were first drawn. This comparison shows the traditional zodiac system on the left, established 2,500 years ago with 12 equal slices. On the right is the modern astronomical map. Today, the sun crosses 13 uneven constellations, spending just 1 week in Scorpius, but over 6 weeks in Virgo. The stars are still in their expected positions relative to each other. The change comes from Earth, as our viewing angle of the universe has drifted over the last 20 centuries. This drift is the result of a massive, continuous movement called axial precession. It is a slow change in the orientation of Earth's rotational axis that alters everything from our seasons to which star we call the North Star. To understand why this happens, we have to look at Earth's true shape, an oblate spheroid. An oblate spheroid is a sphere that is slightly flattened at the poles and bulging at the equator, creating a belt of mass 43 kilometers wider than the planet's height. Because the Earth is tilted, the Sun and Moon pull unequally on this off-center equatorial bulge. Gravity is stronger across shorter distances, so the side of the bulge tilted toward these bodies feels a much harder tug than the side tilted away. This unequal pull creates torque on the spinning planet. Torque is a rotational force that causes an object to twist about an axis. As a spinning object, the Earth responds to this torque by wobbling. This movement follows the exact same physics seen in a household spinning top. This planetary wobble causes the Earth's axis to trace a giant double cone in space. It is a slow process, taking roughly 26,000 years to complete a single circuit. This means our orientation in space is constantly being shifted by the same gravitational laws that dictate our orbit, operating on a hidden 26,000-year clock. Ancient astronomers detected this invisible motion thousands of years before the development of modern orbital mechanics. In the 2nd century BC, the Greek astronomer Hipparchus used lunar eclipses to calculate the position of the star Spica. When he compared his data to records from over a century earlier, he found Spica had moved 2 degrees further west than previously recorded. Hipparchus concluded that the entire celestial sphere was shifting relative to the seasons, a phenomenon he described as the precession of the equinoxes. While astronomers could see the effect, the physical cause remained unknown for nearly 2,000 years, until the scientist Isaac Newton applied his laws of motion to the problem. Newton published the mathematical proof in his Principia, demonstrating that precession is a mechanical consequence of gravitational forces pulling on the Earth's equatorial bulge. This discovery provided the first evidence that the Earth's baseline orientation in the universe is a dynamic, moving value rather than a fixed constant. Because of this 26,000-year wobble, the fixed points we use to navigate the sky are temporary. This star map shows the path Earth's axis traces through the stars. Our axis currently points toward Polaris, today's North Star. 5,000 years ago, it pointed to Thuban in Draco. In 12,000 years, it will point toward Vega, the future North Pole marker. This wobble also creates a gap between the tropical year and the sidereal year. The tropical year is the time between seasons, while the sidereal year is one full orbit relative to the stars. Precession causes them to fall out of sync by about 20 minutes every year. The Earth wobbles through space as it spins and orbits. When you look at a horoscope or the night sky, you are seeing a snapshot of a 26,000-year cycle in a window to the cosmos that is always shifting.